Today we'll talk about section 1.2, which is about the rational numbers. And recall by the definition that every rational number can be written as a ratio or a fraction of two integers. That is, 2/3, for example, is a fraction of two integers. I could also do it like so, 2 times 2/3, but maybe I want to multiply that 2 by a 4, and the 3 by a 4 as well. Now this is equal to the number 8/12. Okay? This number can be reduced. So oftentimes it's easier to notice that there's a common factor. Okay? Factors are two things that are multiplied together. So there's a common factor of 4 to the numerator and the denominator, and cancel those out first. Then you'd just be left with 2/3, which is in fact what 8/12 reduces to. So in general, if we have two things being multiplied, I'm going to write this a little bit bigger, A times C over B times C, and there is a common factor, it is best to cancel that common factor first, and then the reduced form of the fraction will just be the remaining factors. So let me show you what this is. Okay. So for example, this says 54/90. Okay. Well, I know that 90 is 9 times 10. I also know that 54 is 9 times 6. Now I can cancel that common factor, and I'd be left with just 6/10. But notice I could go further, because I know that 6 is 2 times 3, and 10 is 2 times 5. So there's a further common factor of 2 involved. I can cancel that, and we're left with simply 3/5. There is no more common factors, so 54/90 is equivalent to 3/5. Let's try another one. 135/390. Okay. I know there's a common factor of 5 because this ends in 5 and this ends in 0. Okay, so this is divisible by 5. Any number that ends in 0 is also divisible by 5. But let's see if we could find the prime factorization of these. Because as you'll notice here, there was multiple factors to cancel. Now I do prime factorization a little bit differently. If you have your own method of prime factorization, that is fine. Okay? I do mine as an upside down division bar. I'll show you why. If you like the tree, it'll be fine as well. Okay? Now I know 5 goes in here. So 5 goes into 135. 5 goes into 13. 2 times 5 is 10. Subtract to get 3. Bring down the 5. Then 5 goes into 35 7 times. Okay. So what that means then is that 5 goes into 135 27 times. If you're doing the factor tree, it would look like 135 is 5 and 27. Now 27 is not prime. I know that 27 is 3 times 9. Okay. So in my version, I would say 3 goes into 27 9 times. And further, I know that 9 is also not prime. It's 3 times 3. So 3 goes into 9 3 times. Now in the factor tree version, that means the prime factorization of 135 is 5 times 3 times 3 times 3. In my version, the prime numbers are on the outside. Okay. So either way you choose to do it, or if you have your own method, that's fine as well. Okay. So I know I can write 135 is 3 cubed, 3 times 3 times 3 times 3, 3, 3, 3, times 5. Okay. divided by 390. Now let's find the prime factorization of 390. Well, I know 3 goes in. 3 goes into 3 one time, and 3 goes into 9 3 times, and we'll bring 0. This ends in 0, so let's see how many times 5 goes in. 5 goes into 132 times, minus 10. Bringing down the 0 is 3. 5 goes into 36 times. So 26 is remaining. 26 is even, so 2 will go in here 13 times. And it doesn't matter which order you put them in, because remember, multiplication commutes, but the prime factorization is 3 times 5 times 2 times 13. Now when I write them over here, I'm going to order them. 390 is 2 times 3 times 5 times 13. And now I'd like to do the canceling. So this is how you'll do reducing and division without a calculator. So there's a common factor of 5 and a common factor of 5. Those will cancel. Now I have 1 3 here, but 3 3's up top, so that 1 3 will cancel with that 3, and we're left with 3 squared. So in the end, what we're left with is up top 3 squared, which is 9, over 2 times 13, which is 26. And there are no common factors left. There would have to be a 3 down here for us to cancel. And that'll help us when we're trying to reduce things like this. Okay, let me write this so it's a little better. Ax squared y cubed over a squared xy squared. Now this is all multiplication. So let's do the same idea with the reducing. Up top I have 1a, and down below I have 2 a's. So when I cancel out an a, I'm left with the number 1, and I take a single a out, leaving 1a. So the same thing will happen here. There's 1x. X goes into itself 1 time. And if there's 2, then I'm left with a single x up top. Now here I have 2 y's, and up here 3 y's. So I can cancel both y's in the denominator, leaving behind 1 y in the numerator. So what I'm left with is 1 times x, well that's just x, times y, well that's xy, using that identity property of multiplication, and a times 1 times 1, well that's just a. So this expression reduces to xy over a. Now let's do some multiplication. When you're multiplying fractions, a over b times c over d, you can just multiply across to get a over c and b over d. But we would like to do canceling first because it will make our answer reduced. Otherwise we would have to multiply and then reduce. Lots of times we forget to reduce. So here I will look. I have a 3. Is there any common factors of 3? No. I should rewrite this. 4 over 7 times 2 over 3. Okay. There's no common factor of 3 or 7 up top, so we can just multiply 4 times 2, 7 times 3, which is 8 over 21. On the other hand, here we have 6 over 25 times 10 over 27. There is, in fact, common factors. 25 is 5 times 5, so 5 goes in there 5 times, and 5 goes into 10 2 times. Notice to cancel, they don't have to be directly on top of each other because they're multiplying. There's also common factor of 3 here. 3 goes into 27 9 times, and 3 goes into 6 2 times. Now I'm left with 2 times 2, which is 4, over 5 times 9, which is 45. And there's no common factors here, so this is our reduced form. So 6x over y times y squared over 2x cubed. Again, let's do our canceling. Y goes into itself once and into y squared, leaving a y behind. X will go into itself once and into x cubed. Well, if there's 1 here and 3 here, there must be 2 left. But also, let's not forget about the numbers. Okay? 2 goes into itself once and into 6 3 times. So up top, we're left with 3 times 1, which is 3 times y, which is just 3y, over 1 times x squared, which is just x squared. We can also do canceling when we have a rational number times a whole number. The way we're going to do this is remember that we can write any integer as a whole number over 1. Now it'll probably be easier to see the canceling. 6 goes into itself 1 time, and 6 goes into 18 3 times. So up top we're left with negative 5 times 3, which is negative 15. We have the x as well. And 1 times 1 is just 1. So we could write it as over 1, but that's just really negative 15x. Now let me rewrite this 2/3 times 6x minus 9y minus 15. To simplify this, we're going to use the distributive property. So first I'm going to do this just step by step. I take 2/3 times 6x. Then I'm going to take 2/3 times negative 9y. And then I'll take 2/3 times minus 15. I'm leaving out the signs right now because we will simplify those. Okay. Now remember, we can write these as all over 1. Okay. And then we can do the canceling. So 3 goes into 6 2 times. 2 times 2 is 4. And the x will come along. Then 3 goes into itself once and into negative 9, negative 3 times. So we have negative 3 times 2 is negative 6, which becomes a subtraction, and the y comes along. Again, 3 will go into itself 1 time and into 15, negative 5 times. Then negative 5 times positive 2 is negative 10. Now, dividing fractions is almost the same thing as multiplying. Okay. So if you take, in general, a divided by b, then you divide that by c divided by d, well, it's the same thing as keeping the first one, taking the reciprocal of the second, and multiplying. So dividing is the same thing as multiplying by the reciprocal. So if we were to use that, we have 14 over 45 divided by 49 over 10, well, I change the division to a multiplication, but multiply by the reciprocal. And we could just multiply straight across. But again, here's a situation where reducing will help us. I don't want to multiply 45 and 49 by hand. Notice, however, though, there's common factors. 7 goes into 14 2 times, and 7 goes into 49 7 times. 5 goes into 45 9 times, while 5 will go into 10 2 times. So I'm left with 2 times 2, which is 4, over 9 times 7, which is 63. Now with this one, we might be confused to think, I don't have a fraction, so I can't multiply by the reciprocal. But remember, we can create fractions by writing it over 1. Okay? Creates a rational number. So now this becomes 3a over 5bc. I change the division to multiplication and take the reciprocal. Now, I don't want to forget this negative, and if you put the negative down here, lots of times you'll forget it. So I always put it up top so we don't lose it. Now we can do the canceling. We have 1a and 1a, which will cancel. The 3 will go into itself 1 time, and the 6 2 times. And now all I have are 1s up top. So nothing else will cancel. So 1 times negative 1 is negative 1 over 5 times 2 is 10. B times B is B squared, and a C. So that's how you multiply and divide fractions. But when you're adding or subtracting fractions, what you'll need is a common denominator. So if you have a over c plus b over c, that's the same thing as a plus b over c. That is, if I have 1/4 plus 2/4, well, that's the same thing as 1 plus 2 over 4, which is 3/4. This happened because I had a common denominator. Now, what we will need to do is I have unlike denominators here, a over b and c over d. So what I'm going to do is I'll multiply these two common denominators together. I want to get to the least one, and I'll explain that in a minute. But if I multiply these together, I can multiply this side by d and this side by b. Now what I have is AD over BD plus CB over DB. Well, now these are alike. And once they're alike, I can just write it. Now remember, these are alike because multiplication commutes. So B times D is the same as D times B. And add the new, I'm sorry, this should be a D. Plus C times B. So let's see how this works. Okay. Here I have a common denominator, which is 9. So I can rewrite this as 1 minus 4 over 9, which is negative 3 over 9, which I can reduce to negative 1/3. We'll come back to B. Here you might think, I don't have fractions. I can't add or subtract these. But we can. Remember that you can write the number 1 as any number over itself. Since the denominator here is 4, I could write this as 4 over 4 minus 3 over 4. Now I have the common denominator, so this is 1 over 4. Now things get a little more complex. For example, if I let's start this way. Notice my common denominator, I'm trying to find it. 9 factors into 3 times 3, while 6 factors into 2 times 3. So there's already a common 3 between each of these. So what I need to do is I need to look for the least common denominator. I need to take each unique factor between both of them. So there's a 2 and a 3 in the first, and the 9 only has 3's. Okay, so my least common denominator needs 2's and 3's. Then to determine what the least common denominator is, I look, and 2 here represented once. The 2 is not represented here. So between our two denominators, the maximum amount of times the 2 is represented is 1 time. Then I do the same thing for 3. Here the 3 is represented 1 time. Here the 3 is represented twice. So between the two denominators, the maximum amount of times the 3 is represented is 2 times. And this will be our common denominator. Well, 2 to the first power is just 2. 3 squared is 9. Our common denominator is 18. Had you just multiplied these together, you would have said the common denominator is 54, which would work, but you will have much more work to do when reducing. Okay, so let's alter these. So 5 over 6 plus 2 over 9. Okay. So now the question becomes, what do I have to multiply 6 by? Well, 6 is 2 times 3, so I'm missing a single 3. 6 times 3 is 18, so I multiply this one by 3 over 3. 9 times 2 is 18, so I'll multiply this by 2 over 2. Notice I'm multiplying by the number 1. And where in this example, I changed 1 to 4 over 4, just because this had a 4. But these are just the number 1, so I'm not changing the value. And this becomes 5 times 3 is 15 over 18. Plus 2 times 2 is 4 over 18. And now we can add straight across. So 15 plus 4 is 19 over 18. So this is going to take some practice, but you'll get it. And it becomes helpful when we're dealing with variables. So here, our least common denominator, let's figure out what it would be. In the first, we have 2 unique factors, 2 and a. So that has to be involved. And here we have a squared. Okay? So this doesn't add another unique factor. Okay? Now we just determine the maximum amount of times each factor is represented in each denominator. So here 2 is represented 1 time, and 2 is represented 0 times. So the maximum amount of times 2 is represented is once. Here a is represented 1 time. Here a is represented 2 times. So the maximum amount of times that a is represented is 2. And then this just becomes 2 to the first power is 2 times a squared. So this is our least common denominator. Now let's try and get the common denominator. So here I need to multiply to get to 2a squared. I already have a 2 and a single a, so I need to multiply by another a to get to a squared. And here I already have the a squared, but I'm missing the 2. So now we can write this as over 2a squared. The first one, x times a, well, that's the same thing as ax because multiplication commutes. And here w times 2 is the same thing as 2w, again because multiplication commutes, which we can write then as one great big fraction over 2a squared. Okay, so that will take care of section 1.2. It's going to take some practice, but the sooner you get a hold of this, the easier the upcoming sections will be. Please email me if you have any questions.